Hello, we are Team 16 Earthquake Early Warning in Kathmandu, Nepal. I'm Ra, and I'm joined by my two teammates, Sabiata and Safik. So to introduce our project, the 2015 Kathmandu earthquake, which caused thousands of deaths and injuries, highlighted the necessity for an on-site earthquake warning system in Kathmandu, Nepal. Our partner Bass Connections team is working on implementing suitable on-site earthquake warning systems that will use machine learning methods developed from our proof of concept study. In this project, our machine learning models use the faster but less intense P waves to warn about the stronger surface waves. So we aim to relate these waveform characteristics from the P waves to predict expected shaking at the monitor site by using the Gaussian process regression. And we also aim to investigate the Gaussian process regression to see if it is a better predictive model than the currently used linear regression method.
Before we began the machine learning model, we had to interpret our sensor data into input features. For this, we established a methodology to detect a P wave and then computed the 5 input features which correspond to the initial P waves and 2 output features which correspond to the larger surface wave intensity.
Then from there, we computed a multivariate Gaussian process regression. But what is a Gaussian process regression anyway? So the Gaussian process regression models the data as an infinite dimensional multivariate normal distribution with a covariance between points being computed using the kernel function. And this can also be used to model multi-output data. And we use the Python package GPy from Sheffield Machine Learning.
So in our results, we can see that our Gaussian process regression models are outperforming our linear regression models. Over here, we have plotted our Y true versus our Y predicted, and we can see that the points are fairly well and tightly distributed along the central diagonal line, suggesting that the model is performing well.
We also aim to understand the variable importance of the input variables that we used. We use Shapley and length scale to understand which variable is more important, and both of the methodologies correspond that peak acceleration is the most important variable.
We also use something known as the mortality intensity scale. So this intensity scale measures or describes how strongly earthquakes are felt at on-sites. So we have 3 categories over here: weak, medium, and strong. And we observe that for medium plus strong category of earthquakes, we can catch 98% of them, which is a pretty good number and suggests that our model is performing fairly well. Thank you.